Chapter 3, Section 7, Part 2, Solving Absolute Value Inequalities. Absolute value inequalities, there are going to be two different rules. There's going to be one rule for absolute values that are greater than and greater than or equal to a number, and another set of rules for absolute values that are less than and less than or equal to a number. These are rules that really you're just going to have to memorize. I'll try to help you come up with a trick that works for you on how you can remember them, but it's just gonna take some practice and really just sitting down and actually memorizing the rule. You will not be given the rule on any test or quiz that is given over absolute value inequalities. Regardless of the inequality symbol, so whether you have an absolute value that's greater than or an absolute value that's less than a number, regardless of the inequality symbol, we're going to start by isolating the absolute value. Yesterday we had talked about solving absolute value equations. It's going to be the same idea. We're still going to need to use inverse operations to isolate the absolute value in our inequality. After the absolute value is isolated, for the absolute value of A is less than B or less than or equal to B, where A is a variable expression, so capital A, what is inside of the absolute value symbol, it's going to have a variable and or a variable with operations. And B has to be greater than 0. So B, again, B cannot be negative. It has to be a positive number. Solve the compound inequality. You're going to say that negative B is less than A is less than B. So B is going to be the number, and A is what's inside of the absolute value. And if you had a less than or equal to, you're just going to have the less than or equal to symbol. So if it was the absolute value of A is less than or equal to B, it would be negative B is less than or equal to A is less than or equal to B. Notice this is an and compound inequality. We've already talked about solving compound inequalities, and we could have either and or compound inequalities. So if you have the absolute value less than or equal to a positive number, it's going to be an and compound inequality. And then our next rule says that for the absolute value of A is greater than B, and this is also going to work for greater than or equal to, where A is a variable expression, and again, B has to be greater than 0. Solve the compound inequality. This is going to be A is less than negative B, or A is greater than positive B. This could also be, if you had the greater than or equal to, you could say that A is less than or equal to negative B, or A is greater than or equal to B. Like I said, these are just two rules that really you're going to have to memorize. Somehow remind yourself that if the absolute value is less than B, it's going to be an and if the absolute value is greater than the B, it's going to be an or compound inequality, and help yourself remember the symbols and how you write all of this. I think it's really just going to take practice, though. So make sure that you're paying attention and make sure that you are using these rules when you're given your homework. The first example says, what are the solutions of the absolute value of 5x is greater than or equal to 20? Then it asks us to graph the solutions. So you need to look back in your notes that we just wrote down the two rules. We have the absolute value is greater than or equal to a positive number. 20 would be our B in this case, and the 5x would be our A. So the absolute value is already isolated in this case because the absolute value of 5x is on one side of the inequality by itself. Because our absolute value is already isolated, I'm ready to apply one of the rules. Of course, the absolute value is greater than or equal to a number, so I'm going to use the greater than or equal to rule. And I can say that 5x is going to be less than or equal to negative 20, or 5x is going to be greater than 20. Now, this is just solving a compound inequality with or. I need to solve both inequalities. To do that, I need to divide by 5. When I divide by 5 on this, the inequality to the left, my 5's cancel out and I'm left with x is less than or equal to negative 4. Now I need to solve the inequality 5x is greater than or equal to 20. You have to divide by 5 on both sides, and when you do that, you get or x is greater than or equal to 4. Remember, when we have or compound inequalities, you have to shade the opposite in opposite directions. We need a closed dot at negative 4 because it's less than or equal to, and we need a closed dot at positive 4 because it's greater than or equal to. We need to shade x is less than negative 4 and then shade for x is greater than positive 4. So we have solved our inequality and graphed our solutions. The next example says solve each inequality and graph its solution. Again, notice that I have the absolute value, and inside of the absolute value symbol I have n divided by 4, and then is less than or equal to 3. Again, in this example, my absolute value has already been isolated. The absolute value is already alone on one side of the inequality sign. I am ready to rewrite and apply one of the rules that I had talked about. In this case, I have the absolute value is less than or equal to 3. When the absolute value is less than or equal to 3, I can write a compound inequality, that is a compound and inequality. I'm going to leave n divided by 4 alone in the middle, and I can take it out of my inequality symbol, or my absolute value symbol. I'm going to say that negative 3 is less than or equal to n divided by 4, which is less than or equal to a positive 3. Remember, we talked about writing and compound inequalities and how your smallest number always goes on the left, your largest number always goes on the right, and your variable has to be in between. Notice that this is the case for this and compound inequality. I have negative 3 on the left, I have positive 3 on the right, and my variable n is in the middle. Remember, when solving a compound inequality involving and, I can solve all 3 parts at the same time. You're still doing the inverse of what's happening to the variable. So if you look at the variable n, I am dividing it by 4. The inverse of dividing by 4 is multiplying by 4, and I need to do this to all 3 parts of the inequality. When you do negative 3 times a positive 4, you get negative 12. My sign is going to stay the same because I'm multiplying all 3 parts by a positive number, so my sign does not change. N is in the middle, and then 3 times 4 is 12. So you get negative 12 is less than or equal to n, which is less than or equal to positive 12. I need closed dots at negative 12 and a closed dot at positive 12. And because n is greater than negative 12 and less than a positive 12, it is shaded in between the 2 points. The next example says solve each inequality and graph its solution. Notice in this case I have a negative 3 plus the absolute value of n minus 2 is greater than 5. My absolute value is not isolated yet. I have a negative 3 plus the absolute value. I need to get rid of the negative 3. To get rid of a negative 3, I have to add 3 to both sides. When I add 3 to both sides, I get the absolute value of n minus 2 is greater than 8. Because the absolute value is isolated now, I'm ready to apply one of the rules for solving an absolute value inequality. The absolute value of n minus 2 is greater than 8, so I need to apply the first rule that we had talked about, the second rule that we had talked about in our notes. Remember, when we're using that second rule, we're going to have an or compound inequality, and I'm going to say that n minus 2, I'm going to say is less than negative 8, or n minus 2, so notice the n minus 2 doesn't change. We keep what's inside of the absolute value the same, is greater than 8. If you notice my first inequality, the n minus 2 is less than negative 8. What I've done is I have flipped my inequality sign and negated the positive 8 to make it a negative 8. So you could kind of almost think like, well, when I'm making one side a negative, I have to flip the sign, just like if you were multiplying or dividing both sides by a negative, you have to flip the sign. So if one side is changing to a negative, flip the sign. And then notice that my second inequality, n minus 2, is greater than 8. Basically, all I've done to that is taken out the inequality signs. So one of them is just taking out the inequality signs. The other one is flipping and negating your number. That might be a way to help you remember. See if you can come up with something. Again, if that doesn't work for you, then see if you can come up with something on your own. And please feel free to share it in class when we're talking about this. Now that I have the compound inequality, I need to solve both parts. So to solve the n minus 2 is less than negative 8, I need to add 2 to both sides to get n by itself. When I add 2 to both sides, I get n is less than negative 6. Or I need to add 2 again on both of these sides. I'm going to get n is greater than 10 because 8 plus 2 is 10. Now when I'm graphing this solution, I'm going to have an open dot at negative 6 and an open dot at 10. Because it is an or compound inequality, this first one says n is less than negative 6, so I'm going to shade to the left. The next one says n is greater than 10, so I need to shade to the right. Because it's an or compound inequality, the shading is in opposite directions. The last example says solve each inequality and graph its solution. We have the absolute value of x minus 4, and then the whole absolute value is being divided by 5. Notice that 5 is not in the absolute value symbol, and then it is less than or equal to 2. Because the dividing by 5 is not in the absolute value symbol, I do need to get rid of it to isolate the absolute value. In order to get rid of dividing by 5, you have to multiply by 5, and remember you have to do it to both sides. I'm multiplying by a positive, so my inequality symbol does not flip, which does give me the absolute value of x minus 4 is less than or equal to 10. I have isolated my absolute value. The only thing on the left side is the absolute value of x minus 4, and then I have is less than or equal to 10. Because the absolute value is less than or equal to a positive number, I'm going to write a compound inequality, or a compound and inequality. Remember, my variable has to go in the middle, so x minus 4 is going to go in the middle. My negative 10 would have to go on the left. My positive 10 is going to have to go on the right, and I'm going to rewrite the less than symbol in between all three parts. So I have negative 10 is less than or equal to x minus 4, which is less than or equal to 10. Because this is an and compound inequality, I can solve all three parts at the same time. Do the inverse of subtracting 4 because you're subtracting 4 from your variable x. The inverse of subtracting 4 is adding 4. Add 4 to all three parts. negative 10 plus 4 is negative 6, is less than or equal to x, which is less than or equal to 10 plus 4 is 14. I need a closed circle at negative 6 and a closed dot or point at 14. Because this is an and compound inequality, and because this would say that x is greater than or equal to negative 6 and x is less than or equal to 14, I am going to shade between the 2 points. Today's assignment is on page 228, numbers 2 through 20 even, and then number 23.